Change the future. Changing the future of die casting. Changes of metal additive mold manufacturing. Our history with additive manufacturing. 2015, we were introduced to the additive manufacturing business. 2021, opened a new business for AM in-house. 2022, developing new technology. And continue to work on it. 2015, we were introduced to the additive manufacturing business. We proposed metal AM parts using the Service Bureau. We began by doing only post-processing after modeling in-house. It has become possible to propose a waterline design that can achieve better cooling effect. To move on to the next steps, there were some major issues. It is the limitations of the material called merging steel. 1. Due to its low thermal conductivity, it has to have a thin wall design for cooling process, therefore it will easily crack due to thermal stress and will have a short life. 2. In case of the hybrid insert, boundary surface with the different materials is considered weak and likely crack easily. 3. Export restrictions on materials make it difficult to sell globally. Industry's first successful molding with SKD61 equivalent material. In 2021, we took a big step into the AM business. In summer 2021, we opened Tooling Innovation Company Limited as an AM development, manufacturing base and showroom. We installed 2 of GE Additive's Concept Laser M2 for metal 3D printer equipment, along with 2 of 5-axis machining centers and 3-axis machining centers that used for pre-processing of the hybrid base and finishing after molding. A heat treatment furnace for tempering after molding. 3-shot blasting machines for stress relieving and polishing. Also, a dimensional measuring instrument for 3D shape and melt pool 3D visualization analysis software. With these full-scale investments, we started the operation in fall. Production of additive manufacturing molds using SKD61 powder material with metal 3D printers is rare in the industry. So we decided to promote the development for aluminum die-cast molds for automobiles as a group policy. As for the role of the group, Nihon Seiki will deliver die technology innovation and technical proposals based on AM technology, while Dynamo will focus on manufacturing and sales. Tooling Innovation will work on the technical development and manufacturing specializing in AM. With our group, further technological improvement can be expected. The strength of our new business lies in the fact that all processes, from analysis, design, molding, heat treatment, machining, measurement, inspection, to after-sales follow-up, can be produced in-house. By doing all the molding and heat treatment processes in-house, we can identify the root cause when problem occurs, which is useful for further improvement. As a result, losses and risks can be minimized, and quality cost delivery can be expected. Since we are a mold maker, we aim to make the best functional and quality for our end products. In November, we established a quality assurance system to spread the use of AM molds. While AM technology makes it possible to create complex internal mechanisms that were difficult with conventional machining methods, it is difficult to verify internal attributes and physical properties such as melting defects and internal shapes. Then, we acquired the analysis software called VG Studio Max, made by Volume Graphics. The Melt Pool 3D visualization function of VG Studio Max allows us to superimpose image data for each layer taken with a photodiode camera, then calculate it as 3D volume data, and visualize it. This data has made it possible to view the internal structure, features, and melt defects that we were unable to previously view from the exterior. It also allows us to perform non-destructive testing, such as dimensional measurement, shape comparison, and defect analysis. Now we can provide the safety that has never been existed before to our customers. We believe that the internal quality assurance through visualization of metal AM molds is the first in this industry. We use Dow Steel's Di-Steel High Thermal Conductivity Powder Material, HTC45. HTC45 is a powder material with reduced amount of carbon added to the minimum extent, in order to obtain the hardness required for die-cast molds, and improves moldability. Tensile strength and Charpy impact value are equal to or higher than SKD61 steel of the same hardness. Because of a low rate of silicon, thermal conductivity improved by 2 times that of maraging steel and 1.5 times more than SKD61. By combining with GE Additive Concept Laser M2 equipment, the average of molding density can reach 99.9962%. Comparing the usage of conventional maraging metal powder. Using a high thermal conductivity powder material, HTC45, this will reduce thermal stress and prevent cracks, also leads to longer mold life. Molds made with HTC45 have higher cooling efficiency than molds made from SKD61, and the mold temperature is reduced. It is also effective in preventing seizure and contributing to faster cycle speeds. Solving the problem of maraging metal powder with HTC45. By using a high thermal conductivity powder material, HTC45, we will obtain twice the cooling effect than with maraging steels. There is no need to have thin wall design. This will reduce thermal stress and prevent cracks, also leads to longer mold life. Since there is no difference in the coefficient of thermal expansion, it is difficult to generate cracks from the boundary surface during mass production. Since it does not contain cobalt, so it can be sold globally. (2022). This year, we started 3 new technology development projects. Development of process for improving down skin and surface roughness. Development of internal flow path cleaning equipment to use for maintenance. Challenges in thermal control of large size insert. Promoting 3 new technological development projects, and aiming to standardize AM specifications in mold design. Finally, creating our partnerships. Thanks to our cooperative partners. Without their supports, their specialists in respective fields, their cooperation, we cannot be where we are now. By combining their knowledge and technologies, we will elevate this industry to a further stage, and we will face these challenges together, so that we can share and spread this amazing technology to the world. In this kind of environment, as we are moving toward to an era in which electric vehicles, EV, play a leading role, the number of die-cast aluminum parts of the powertrain system will drastically decrease. As a way to reduce the weight of stamped parts, we think die-cast aluminum and larger size of mold will gradually change the common sense of the industry. I think the time to make changes to this business has come. We need to make the most use of AM technology to move forward with the aim of creating more value-added molds.